All right, welcome AP Calc. Let's do this. Lesson number 17, the chain rule, day one. So this chain rule, what is it and how does it help us? Let's just imagine we have this function 5x plus 3 squared, right? And we want to take the derivative of this. So let's, work our magic. We'll say that f of x is equal to 5x plus 3, the whole thing squared, and what we want to do is find the derivative of this. So before we even take the derivative of this, notice it's in a weird format, right? And how would we actually expand this out? So think of this as 5x plus 3 times 5x plus 3, right? We have two of these 5x plus 3s, and let's FOIL it. Okay, pause the video and FOIL it and see what you get. And if you FOIL this, 5x times 5x is 25x squared, 5x times 3 is 15x, then we have another 15x, and then we have a 9 over here. And we know that f of x is equal to 25x squared plus 30x plus 9, right? And if we were to say, oh, what's the derivative of f of x? Well, that's just easy money, right? You say f prime of x is equal to, okay, use the power rule, so that's 50x plus 30. And you just put a smile on your face and say, okay, Mr. G, no problem. We could do that very nicely. But this was a little annoying. I don't feel like doing this all the time. And what's really nice, this technique, the chain rule, what it's basically allowing us to say is, if we have a function that's in this format where we have some composite function, some f of g of x, right? What we're allowed to do is we're allowed to take the derivative of the outside times the derivative of the inside, okay? So what I want you to do is just take a second and copy this down. And definitely for this lesson, before you gotta pause the video, you're gonna need a blue, a black, and well, actually, you just need a blue and a red pen, okay? If you want to use a pencil, that's okay. But definitely get a blue and a red pen. And I think I should give you one in class today. But okay, so have this down, and we'll see why colors are going to be really important, okay? And notice that the outside is red and the inside is blue. So how can we find the derivative of this using the chain rule? And the idea is, well, let's first start this off. So first, let's just write it. F of x is equal to 5x plus 3, the whole thing squared. And the idea is, using our red, notice that we're going to take the derivative of the outside. So the way we're going to set this up is, notice that what is our outside over here? It'll be this parentheses squared. Okay, that's going to be our outside. And what's going to be our inside, it's going to be this 5x plus 3. And notice that it's in blue. And if you have any problems with like seeing color, just let me know, because I think I'm not sure about all of you, but just let me know if you have problems seeing color. But to continue on, what's the idea of this? It's saying take the derivative of the outside, which is the red, times the derivative of what's in the inside. So notice that if I were to take the derivative of the outside, just looking at the red over here, it's not that crazy, but just imagine like the power rule. Like if I said, what's the derivative of 3x squared? What are you going to do? It's just 2 times the 3, right? This is 6x. And that's the same idea here. Imagine there's a 1 there. This is 2 times 1. So this is 2. And then we're going to take what's here, okay? And how do we take the derivative of the outside? Notice, what do I do with the exponent? It's 2 minus 1. So there's an invisible 1 here, right? And now here, what's the next thing we're going to do? And this is a 1, by the way. You see, first we took the derivative of the outside. Now we're going to take the derivative of the inside. So what is the derivative of 5x plus 3? And notice that the derivative of 5x plus 3, this is just 5x, okay? But then what happens over here? Notice this just becomes 2 times 5x plus 3, okay? And, oh, I'm sorry, this should be a 5 here, right? And so what do? What's this? 2 times 5x is 10x. 2 times 3 is 6. And then we're going to multiply this whole thing by 5. And notice that what are we going to get? 5 times 10x is 50x, and 5 times 6 is 30. And notice that this is the same thing that we got before of 50x plus 30 for f prime of x, okay? And this idea of the chain rule is very, very helpful, okay? And to get used to the what's the outside and what's the inside, that'll take some time. So let's do the next question. What I want you to do is get your red, get your blue, okay? And let's set this one up. So let's look at example number 2. Let me zoom in. So here, let's say if we have f of x, right? First, let's write it. F of x equals 4 minus x squared, the whole thing cubed. Now, I don't want to have to cube this. I don't want to do what I did over here, where I have to cube it and then do all the algebra to get the derivative. What we're going to do is we're going to use this setup with the chain rule. So over here, let's first set it up. What's the outside? What's the inside? Okay, so take your time using your colors. What would be considered the outside for f of x? Okay, pause the video. Okay, so here f of x is equal to, all right, what's our outside? Our outside is right here, the parentheses. And what will be the inside? It's this 4 minus x squared. So how do we take the derivative? First, we take the derivative of the red, of the outside, right? So what's the derivative of the outside? Here, it's just 3 parentheses 4 minus x squared. And notice, you see how we're not going to touch this yet, right? And then taking the power rule, right? This is a 2 over here, times, then what's next? You see, first we took the derivative of the outside. Now we take the derivative of the inside. So the way I'm going to set this up is, I'm just going to write this. And what this is implying is, this implies we're taking the derivative of this. We haven't taken the derivative of the inside yet first. All we did was take the derivative of the outside. So here, this just becomes 3 times 4 minus x squared, the whole thing squared, right, from this. But now we have to take the derivative of this. So what's the derivative of 4 minus x squared? This should be just negative 2x, okay? And that's all we're going to do. We're just going to multiply this to the outside part over here. So this just becomes negative 6x times 4 minus x squared, the whole thing squared. And that's it. And that is our solution over here. And I'll box it in purple. Okay. And this is the chain rule. So the derivative of this function is this function here. And we don't need to expand this. You could just leave it the way it is. All right. What I want you to do is, let's turn the page. Okay. And let's try and do this one over here. And here it says, find dy dx and leave it in any form. Okay. And we're going to use the chain rule. So think outside, inside. Okay. So first what I want you to do is just set it up. That's the first move, set it up. So using the colors, what is our outside? What is our inside? Okay, so take your time. Pause the video, right? So what is our outside? This is our outside. And this is the inside. Okay. And then what do we need to do? Well, we need to first take the derivative of the outside, right? So if I say dy dx, right? Because remember, if I say dy dx, that's another way of saying the derivative. So here, what's the derivative of the outside? So it's 5 times negative 2, which is negative 10, times 5x minus 7. And we're just taking the derivative of the outside, right? And this becomes a 4 because we're doing 5 minus 1, times, okay? Now let's set it up. We got to take the derivative of the inside. And that's what I'm going to, this notation here, this prime implies we're taking the derivative of this. So now here, this stays the same. Times, well, what's the derivative of 5x minus 7? It's just 5x. And notice that what are we going to do? We're going to bring this guy over here because we're just going to multiply the negative 10 to this. So dy dx is equal to negative 50x times 5x minus 7, the whole thing to the fourth. Okay? And the problem is saying leave it in any form. I guess you could leave it like this, but I want you to get into the habit of knowing that to fully simplify this, that this guy belongs here by multiplying from here to here. Okay? Okay. What I want you to do is take your time, you know, try not to just watch me do everything. Same idea here, find dy dx, set it up using the colors, and take the derivative, all right? So what would the setup be for this one? So here, this is y equals, this is, first we go outside, then we go inside. Okay. So here, to find dy dx, we first take the derivative on the outside, so it becomes 3 times negative 7x squared minus x, the whole thing squared, right? Because here we're going 3 times that 1 over here, and then this we don't touch yet, and then you're doing that 3 minus 1 from the power rule, and then here we got to take the derivative of, this is derivative of the outside, now we take derivative of the inside. So let's just set it up, let's just write it out, okay? So then again, let's rewrite dy dx is equal to 3 times negative 7x squared minus x parentheses squared times, well, what's the derivative of here? This is negative 14x minus 1. Okay, and then here, I guess you could just leave it like this. That's fine, because here you would just have it like 3 times negative 14x minus 1 times negative 7x squared minus x, the whole thing squared. And that's dy dx. Okay. All right. I bet some of you probably got that. You know, I'm hoping you got that. But if you didn't, hopefully it's feeling a little better. Try and do the next one by yourself. Don't wait for me. Okay. Try this one. Pause the video. Okay. How do we set it up? First, y equals, right? Okay, what's our outside? Our outside is 5 parentheses 5. Okay, what's our inside? Negative 5x cubed minus x squared plus 3. Okay, dy dx equals 5 times 5 is 25, parentheses negative 5x cubed. Oh no, it's running out of ink. Oh crap. Cube minus x squared plus 3, 4, wait, okay. Times the derivative of this outside part over here, and I don't have space for it, but just, you know, this goes here, right? Okay. So let me put this over here. So dy dx equals 25 negative 5x cubed minus x squared plus 3, the whole thing to the fourth, times the derivative of what's on the inside, which is here. So that's negative 15x squared minus 2x. And oh wait, this should be, yeah, that's okay. And that's it. And if you want to bring this over here, what would it be? Just 25 negative 15x squared minus 2x times negative 5x cubed minus x squared plus 3, and this is dy dx. Okay, and here we go. Let me just make sure that is everything okay? This is plus 3. This looks good. Take the derivative of this, negative 15x squared minus 2x. Yeah, looks great. Happy face. Okay, everybody, let's go. Try the next one by yourself, and let's see what you get. Okay. So dy dx. I'm sorry. First, let's set it up. Y equals. What's on the outside? First, it's -3, and then we have this -1, right? Okay. And what's the inside? We have -2x cubed plus 4x squared plus... Now, if you see the square root of x, I'm going to just have it as x to the 1/2. Okay? Because that's how you're going to have to take the derivative of square root of x, right? So now here, let's say dy dx is equal to -1 times 3 is -3, parentheses, -2x cubed plus 4x squared plus x to the 1/2, parentheses, now this should be -2, times the derivative of this, of -2x cubed plus 4x squared plus x to the 1/2, and we're going to take the derivative of the inside. Okay, and you see how here I put a prime over here. Okay, so dy dx equals what? So here this stays the same, so this is -3, -2x cubed plus 4x squared plus x to the 1/2 to the -2 times, now what's the derivative of this? This becomes -6x squared plus 8x plus 1/2 x to the -1/2. Okay, that's how you take the derivative of x to the 1/2. Okay, because here you're doing, like if I were to show here, 1/2 is over here, and then 1/2 minus 1 is -1/2. Okay, and then here you could just leave it like this, and then because it'll be annoying to like have to rewrite it, but this is it. And I should have done that in purple, but okay. Great. What I want you to do is try Delta Math assignment. Try the Delta Math assignment on your own and practice, practice, practice. Okay. And on the next video, I'll show you the second part where the it gets a little more. They get a little more complicated, but still the same rule applies. Okay. Great job.